Welcome to the class, Tatu. Welcome to the class.
Hello, sir.
Just waiting. Welcome to the class, Bianca. Just switch on your mic so that we can see you and hear you. I sent some work along which you can do as revision. We know you're doing that test or that term task or whatever.
Me, sir.
Yeah, anyone. We know you're going to do it.
I'm planning on doing it this week, sir.
All right. So you haven't had a look.
Yes, sir.
Hi, Bianca.
Hello, sir.
We know you're going to do your task for the term.
I was thinking of doing it this weekend.
Okay. So then next week we can discuss problems if you have or questions. We are going to be with graphs today and functions.
Okay.
And we're just going to do a couple of play around with a couple of graphs. I don't know, how much work have you put into graphs lately?
Like, I started about last week with sin and tan and cost graphs on Monday.
What about
Last week.
Wobbler?
I do know how to do those, but I still need to get into a little bit of depth with those. So I am going to start revising through that.
And Tatu, what about you?
I only struggle on like the cosine and the
Okay, so you actually want to do trig graphs today.
Yes, sir.
And Bianca?
Yes, sir.
Yes, sir.
Okay. Oh, good. I don't know if it's good. So you want to do it from scratch?
Yes, sir.
Yes, sir.
Okay, so let's just, this idea that what we're going to do today is just bombed. Okay, three graphs. Okay, so let's look at that. Okay, we're going to start here. We're going to look at grade 10 stuff and just also it's applicable for grade 11, but just basic trig graphs. I'm just going to pull up a worksheet I've got, just see if it's just going to be easier for me just to drop in the graphs instead of just drawing them. Just give me a second. I just want to see what I've got here. Nope, it's not going to help a lot. Okay, this might help. Okay, let's look at this. Let's just look at the basics. Y equals sin x. So in actually what it says there with the graph is y equals a sin bx plus c. That's your like a standard sin graph.
Sir. Okay,
and it looks something like this. There's your axis, and on your graph will look something like this. Is that correct? Yes. And then we have 90 degrees and 1. And there will be 180 degrees. And on this turning point at the bottom here will be 270 and minus 1 and 360 degrees. Is that correct?
Yes, sir.
All right, cool. So what does it actually say? It says the following. Y equals 1 sin 1x plus 0. Right, let's look at that A value. That A value is called amplitude. And that basically just tells you how high or low the graph is stretched. So amplitude, basically what you do, you take the difference in length between your highest and lowest point, which is 2 units. I don't know if you can see that. From positive 1 to negative 1 is 2 units. And then you just divide that with 2. Take the average, in other words. So that's a 1. Then your B value Your B value is the amount of graphs, very important, you can draw, not is drawn, you can draw in period. So the sin graph has a period of 360 degrees. So how many graphs can we draw in 360 degrees? We can only draw one.
One.
So there's a 1 there. And then the C value here is just if the graph is moved up or down movement. So if the graph is shifted up 1 or shifted 1 down, then you have a +1 or a -1. It can also shift 2 units up, then it's +2, or 2 units down, it's -2 or whatever. Right, just take a screenshot of that. And then when you just play with the sin graph. Just these basic ones. We can do it with cos as well, and then we're going to move the graph left and right as well. Do you have a screenshot?
Yes, sir.
Bianca?
Yes, sir.
Okay, good. So say for instance, I want to draw the following graph. Y equals 2 sin x plus 1. And I want to draw it in the interval where x is an element of, let's say, -90 to 360. Let's make it 360. 360. Okay. There's my y-axis and there's my x-axis. So the way I'm going to do it, I'm first going to draw the 2 sin x part and then just move it up 1. So you use your normal sin graph as a reference. There's also a way of drawing it on the calculator. I don't know if you're aware of that. I'll show you now. So this is my normal sin graph. There it goes. Boom. And this is my key in doing this graph. So this basic graph you know off by heart, or you have to know off by heart if you want to do this graphic method. Okay, so there's a sin graph. So, but that's not the answer. I have 2 sin x and 2 sin 1x. So 2 sin 1x means I have an amplitude of 2 and I can only draw one graph to 360 degrees. So in other words, if I want to just draw that one part, it would look something like this. There's my normal sin graph, but now it will have an amplitude of 2. So a 90, 2, this will still be 180, and that will be 270 and -2 and 360. And if I want to go 90 degrees back, I just flip it back this part. So this is -90 and -2. Would you be able to do that?
Yes, sir.
But that is only this little part at the beginning. I have to move that graph 1 unit up. So certain students move the graph up, or they move the x-axis 1 down. That's another way of doing it. You can actually just do this. So certain students, instead of moving the graph up, they take the x-axis and move it 1 down. I don't like that method a lot. So I'm not going to teach it to you. I'm rather going to move the graph up 1 unit. Okay, so what I'm going to do, I'm going to make this one small because this is our next reference. And then I'm going to draw the graph properly. So there's a graphic way of doing it. In other words, you use this, the standard sin graph as a reference to start drawing from. Would you be able to draw this graph, 2 sin x plus 1?
Yes, sir.
Okay, so it's easy.
Yes, sir.
Good. Okay, so it goes up, comes down, goes up. Okay, so I'll move quicker then. So this will be -90 and -1 because it moved 1 up. That will be 1. This will be 90 and 3. This will be 270 and -1. And this will be 360 and 1. So you'll be able to do that.
So I would be able to do that.
All of you. Okay, cool. Right. So now I want to ask a couple of questions on that graph, just to make sure that you can actually do this basics graph. I want to know the following. Question 1. So you can either quickly draw that graph, and I want to know for which values of x, let's say this graph is f, will fx be larger or equal than 0? Quickly draw that graph and answer those questions. And this will be like 4 marks. See if you can answer that. If you can answer that, then you're fine with the basics of these graphs. You might want to send me examples based of what you can't do. Then I'll start moving the graph left and right. We'll do one cos, and then we'll move sin and cos left and right. We'll leave tan for now.
Yes, sir.
Tan is actually the easiest one of the two. The easier one of the 3. Good. Do you know what to do?
So I am a little bit confused.
Okay, good. Right, so what they're asking is, okay, we could all draw the graph. That was fine.
Yes, sir.
Remember that I show you how to draw the graph with your calculator. The calculator will give you all the
Yes.
coordinates.
Yes,
Right.
sir.
So when is they're asking you the following. Give me the x values. Give me the x values where the graph is larger or smaller than 0. Now I'm going to, in yellow, show you where the graph is larger or equal than 0. All this yellow part, the graph is positive or above the x-axis. So they want to know the x values there, which tells us we need to find all the x values on those blue spots.
Okay.
So the first part is between the first 2 blue spots, and the last part is after the third one. To get that, I need to take the equation of the graph and make it equal to 0, because that will give me the x-intercept. Making y 0 or setting the graph equal to 0 will give me those intercepts. So 2 sin x equals -1. So sin x equals -1/2. And then I type in shift sin -1/2. And then I get x equals -30 degrees. You should first do trig, then trig graphs, because they'll teach you how to do this. -30. Okay, cool. Can anyone give me the next coordinate? It took 120 degrees to go right to 90 degrees. Can you see that?
Yes, sir.
So another 120 degrees to the right will give me 210. And then there's between 210 and 70, there's 60 degrees. And another 60 degrees added, or 30 back from 360 will give me 330 degrees.
Yeah.
So x is -30, 210, or 330 degrees. Did you see how I did that with the symmetry of the graph?
Yes, sir.
Yes, sir.
So now, when is the graph larger or equal than 0? Everywhere where it's yellow. The first section is between -30 and 210 degrees. So this is where x is larger or equal than -30 or smaller or equal than 210. The next section is where the x values are larger or equal than 330. Okay, but we're only allowed to work to 360. So I'm just going to restructure that. So this is where x is larger or equal than 330 and smaller or equal than 360. Just that section there. Those two sections, the graph is above the x-axis, so it's larger or equal than 0. Snap.
Yes, sir.
Right. I'm going to test you on a cos graph on your own. I want you to draw g of x, and that equals, let's say, 2 cos 2x where x is an element of, let's say, negative 90 to 180 degrees. Quickly draw that graph on a system of axes. You can use your calculator if you know how. Do you know how to use a calculator?
I didn't know how to like.
Not.
No, sir.
Right. Quickly draw the graph, then I'll take you through the steps. I need to get that emulator. Tell me when you're ready.
Yes, sir.
Yes, sir.
Okay, good. Right, so what do we have here? We have a cost graph. My reference looks something like this. Well, basically exactly. There's my normal cost graph. This is 180 and minus 1. There I have 360. There I have just 1, 0 and 1. This is 90. This is 270. But what does 2 cos 2x means? It means it's got an amplitude of 2. So the graph basically goes what? Up and down 2, or stretches up. So that
Yes, sir.
basic graph becomes 2 there and negative 2 there. And then I'm drawing 2 graphs to 360. I can draw 2 graphs in its period of 360 degrees. So therefore I can draw 1 graph to 180 degrees. 180 and 2. So halfway to 180 is 90 and negative 2. Then halfway all the way to 180 is what? Is 135. That's 45, 45. And that is 45 and 0. Oops, 45 degrees. And that is 1. And then negative 90 just goes 90 back. Negative 90 and negative 2. Okay, what you can do with your calculator. Okay, switch your calculator on. Do you have your calculator in front of you?
Sir.
Yes, sir.
Switch it on, press the mode button, it's next to on. And then you do table, it's number 3.
Yes, sir.
Will give you fx, isn't it?
Yes, sir.
Type
So
2 cos, and then in that, then there's a bracket, then you type 2 again, and then find the alpha button, it's next to shift. Press it, and then x is just on top of the closing bracket. So you need to type in 2 cos bracket 2x close bracket. Tatu?
Yes, sir.
Then you enter, and my calculator asks gx, but I don't have another graph, so I'm just pressing enter again. Then it asks you, where do you want to start? You say, okay, fine, I'm starting my graph at negative 90, so I type in negative 90, and then enter again, or equals. Then they ask, where do you want to end? Then I say, okay, I want to end at 180. Enter, and then for asking steps. Now, steps is either 30 degrees or 45 degrees.
will they give that to us, sir?
No, you have to guess.
Okay.
I normally guess.
Okay.
I normally guess 45 degrees. If it doesn't look nice, then I just redo it with 30 degrees. So steps, I'm going to type in 45 and then enter. Then it's going to give me a table with X and Y values. Now, the first value in the table is negative 90 and negative 2. Could you see that?
Yes, sir.
Yeah.
The next value is negative 45 and 0.
Yes,
Then I
sir.
have 0 and 2. So there's a mistake there. It was 2. And I scroll down. I got 45 and 0, 90 and -2, 135 and 0, and 180 and 2. So there's all my coordinates on the graph.
Yes.
And then you must just remember to press mode again and comp for computer. Otherwise, your calculator can't do normal calculations.
Thank you, sir.
Here we
So
go.
thank you, sir.
For what value of x will gx be smaller than 0? So they're asking, when is the graph negative? This little green section there, and this little green section there. Okay, but that doesn't help. They want to know what is the x values there. Okay, the first green section starts at -90 and it ends at -45. So x must be larger than -90. So it's further larger is to the right or smaller than -45. There's a little mistake I've made. I'll show you now. It can also be equal to -90. Because when it's equal to -90, it's still negative or below the x-axis. The other section is this green section here. This starts at +45 and it ends at 135. So your x values must be larger than 45. If it's not larger, it's equal to 0. Remember, when it's exactly 45, the graph will be 0 or on the x-axis. It's not allowed to be 0. It's only allowed to be smaller than 0. And the other value is smaller than 135. Okay, look at that and say if you understand what they're doing there.
Yes, sir.
Yes, sir.
Good. Do you want to do a tan graph?
Yes, please.
Yes, please, sir.
We're going to do, this is all grade 10 stuff we're doing at the moment. So let's say fx is, let's say, 2 tan x minus 1. Now, important, tan has a period of 180 degrees. Sin and cos both have 360 degrees, periods of 360. So in one tan graph takes 180 degrees to draw it, while one sin and one cos graph takes 360 degrees to draw. I'm just going to draw the basic tan graph to start with. There's my basic tan graph. And this is at 90 and 270, it's undefined. So there's a one graph, it's finished already at 180. Then the second graph starts. And I have one coordinate here of 45 and 1. This is just y equals 1 tan 1x. But now I have 2 tan x minus 1. So it's basically the exact graph. That value there is just going to be a 2. And we're going to move the graph 1 down. Right, so I'm going to start here. Let's put in those asymptotes at 90 and 270. And then my graph starts at -1 because it started at 0. Now I moved it 1 down. Goes up. The 180 degree marker is also going to move 1 down. So this is -1. And it goes up there. And then the 360 is going to start there. It moves down there, moving down there. Okay, let's just get an interval. Say for instance, I had to draw it where x is element of -90 to 360. Now I still have to, let's just put that coordinate in there. This is 360 and -1. This is 180 and -1. I have to go 90 back. So this is -90 here. And I'm just going to take that graph and squeeze it down. You can do exactly the same on a calculator. You can type in mode table and fx, then you can type in 2 tan and then alpha x close the bracket minus 1. Make sure that you can type in that exactly in your calculator. There's just going to, in your calculator, be brackets around the x. And then equal, gx is not a graph, there's not another graph. And then we're going to start at negative 90 again. We're going to end at 360. And we're going to do steps of 45 degrees. And your table is going to be there. Negative 90 and error. You see that error?
Yes, sir.
Error means it's undefined. It's never going to touch that value. The next one is negative 45 and negative 3. We didn't put that in. We have 0 and negative 1. So that coordinate is in. Then I have 0 and negative 1. Okay, that's in. I've got 45 and 1. I didn't put that in. I have 90 and error. I have 135 and negative 3. So maybe we can just put that coordinate in there. 135 and negative 3. So one coordinate there. And then 180 and 1 minus 1, we have it. We didn't put all that coordinates in. 270 is asymptote, correct. We didn't put in 315, it's not necessary. 360 and minus 1. You only need to put in 3 coordinates. You don't need to put in all the coordinates. So that was easy. So what we've done now, we've done the basic graphs that you've also done last year. Now we're going to start moving graphs left and right. I don't think there's any trig graphs in your assignment, eh? I'm not sure. I had a quick look at it. I don't even know where it is now. So say for instance, we have y equals cos x minus 30 degrees. And we have to draw that graph if x is an element of negative 90 to 270. How are we going to draw that graph? Have you worked with trig graphs moving left and right?
No, sir.
Okay, good. We're going to do this again. We're going to start with a normal cos graph as a reference. So there's 190, 180 and minus 1. This is the graph you'd have to learn off by heart. This is a normal cos graph. 260 and 1. Now certain students just say, look, it's too problematic. They're just going to remember if there's a negative there, it moves to the right. If there's a positive there, it moves to the left. But there's some logic behind it that I'm going to show you. So there's my axis. So I'm just going to ask myself, this value we got here right at the beginning, that one there, where the graph started, which is 0 and 1. How will I get 0 degrees again there in that bracket? To get 0 degrees in that bracket, I have to start at 30 degrees. Because if I put a 30 in x's place, I get 30 minus 30, and that's 0. So basically, this graph just starts at 30 degrees. So at 30 degrees, I'm just going to draw a cos graph. Well, let's try and draw another one, better one. Right, so that value there is going to be 30 degrees and 1. Well, this value here, that was 90 degrees. So now we can clearly see that the graph is moving to the right at 30 degrees. So that value is going to be 30 plus 90, which is 120. And this 180 value at the bottom is going to be just 30 added, 210 and minus 1. And we had a 270 there, which is 30 more. That's now 300 degrees. And we have what? The 360 here. You see, the problem is I have already overshot the graph. I'm not allowed to go beyond 270. So basically 270 is here somewhere. There.
Yes, sir.
So I'm just going to redo this graph. And then I'm just going to take my pencil stuff and delete it. There's the graph. And this is now 270. And I don't know the y value, but I can take my calculator and put the y value in there. So if I type in, just want to fix the calculator. If I type in cos bracket 270 minus 30, close the bracket, then I get negative half. So that's what my y value is. Okay, cool. Now I have to go back 90 degrees. So this was, if I go back 90 degrees on my initial graph, it will be there somewhere now. So going back 90 degrees will not be 90 now. It will be 90 moved 30 to the right. So this one will be just negative 60 there. So I have to continue with the graph. Somewhere there. There somewhere. Okay. Now I'll just go back and type in the x place, I type in a negative 90. And I'm going to get what? I'm going to get negative half. So negative 90 and negative half. There's the graph. It moved 30 degrees to the right. So now you can test this by typing in mode table and then fx again. So I'm going to do cos bracket and I do alpha x minus 30, close the bracket. Okay, type that in. Type in your calculator cos bracket x minus 30, close bracket in that table mode. And then gx is nothing. Then we start at negative 90. We end at 270. And the steps, what are we going to use? Well,
45.
okay, let's use 45. Enter. If I use 45, I can see on my values, I get all weird numbers. Type that in.
Okay.
See, you got all the weird numbers. Why? 45 was not a good option. So I'm just going to go back. I'm just going to clear the calculator. And it takes me back to fx cos x. So I press AC. Then I just run through the steps again. And instead of 45, I choose 30 degrees.
Okay.
I get better values. There's negative 90 and negative 0.5 and half, negative 60 and 0, negative 30 we don't have in, so we can scroll down. Then you have 30 and 1, 120 and 0, 210 minus 1, and 270 and negative 0.5. So a lot of students, when they draw graphs, they just type it in the calculator. They know where the coordinates are. They just draw the curve. Good. Let's do a cos, a sin, and a tan, moving left, right. Right. So the next graph is y equals sin, let's say 60 or x plus 60. Let's keep it x first. X plus 60 degrees. Did we do? Yeah. So now a lot of students do the following. If there's a positive there, I know the graph is going to move left 60 degrees. So they already know that it's a normal sin graph. There's my normal sin graph. And all they're going to do is move it or shift it 60 to the left. Okay, let's just use this normal sin graph. There's 90 and 1. We add 180 there. We have 270 and minus 1. 60. So what they do, take this axis. Okay, let's say we're going to draw the graph where x is the element of negative 90 to 360. So take the sin graph and move this coordinate here. This one there, the 0 and 0. Move it 60 to the left. Okay, my reasoning is the following. I want to get the 0 in the bracket. So I need to start at negative 60. There we start. And then I'm just going to draw the sin graph. There we go. Remember, I'm not trying to stop the graph. I'm just drawing. My hand is used to drawing a big sin graph or a normal full sin graph. So I just draw the full sin graph. So this will be negative 60 there. And then that 90 and 1 becomes 30 and 1. And then 180 becomes 60 less. So that's 120. And this 270 becomes 60 less. So it's 210. And this 360 becomes 300. So the graph's not finished. I have to finish it off here somewhere. 360. So now I type in with my calculator sin of 360 plus 60, and then I get root 3 over 2. Now I have to go back. Negative 60 is not finished yet. I have to finish at negative 90. So negative 90 will be here somewhere. So negative 90, and I type that in the calculator. What's that? Sin of negative 90 plus 60 is negative 30, and that's negative a half. Just check. Just confirm that. Sin of negative 90 plus 60 will be negative half. Yeah. So that's negative half. Copy that or snap that or have a look at that.
Yes, sir.
Are you happy?
Yes,
Let
sir.
me just take a snap, so.
Okay.
Yes, sir.
Good. So I'm going to try and leave you with the tan graph for a minute. Y equals tan of x plus, say 45. And we're going to draw that where x is an element of negative 90 to just like 180. Small graph. You can cheat on the calculator if you want to. The only problem with the calculator, it doesn't help you understand the graph. If you can draw it without the calculator, you can actually interpret the lines as well.
Yes, sir.
You managing?
Yes, sir.
Yes, sir.
Okay, I'm just going to do this for my own reference. 90 to 70. That was your old tan graph or the normal one. Okay. Could have drawn it on if you want to. Right. So now what happened? We started at 0 and 0. So I want to get a 0 in there again. So I just need to start at negative 45. The whole graph moves 45 to the left. But like I said, most students just see that positive there or that plus, and they say, okay, everything moves to the left with 45 degrees. So then you can put in your asymptotes to the left, 45. And the other one will be 270 minus 45, which is 235. No, 225. No. Good. And that 180 degrees will also move to the left. Where? 45 to the left, and that's 135. Okay, so this graph starts here. It will go all the way up there. It will go down there. And it will go up here. But somewhere here it will stop. Remember, we're not allowed to go beyond 180. And negative 45, what will be on the previous, on the normal graph, my asymptote was at minus 90. So now it will be somewhere here at 45 back. So this will be minus 135. So it won't reach there. I have to draw to negative 90. This was minus 45. So the graph will stop here somewhere. I can get those coordinates, let's say A and B, if I want to, by just putting in negative 90 into the equation and plus 180 in the equation. So I'm going to type that in. I can type in tan of negative 90 plus 45. I'm probably going to get negative 1, yes. Negative 90 and negative 1. And then I'm going to type in 180 plus 45. Then I get 1. So there's my graph. You can also do it on the calculator. So you can test that if you want to. Did you all get this?
Yes, sir.
Yes, sir.
Good. Very good. Okay, I'm going to go into the other direction by giving you a graph first, and then you must determine the equation, all the other stuff. So I'm going to make it difficult. Just give me a second so I can copy stuff. Right. Paste. And just the questions as well. Okay, they're telling you, look, it's not very difficult to see the two different types of graphs. They tell you that one F is a sin graph and the other one is a tan graph. So the red one is definitely a tan graph. And the black one is a sin graph. So they want you to calculate the values of A, B, C, D, and X, D and E. So let's start with A. This value there. A is the amplitude of the black or sin graph. How do I get the amplitude? You take the top to the bottom value, which is negative 3. What's that length? It's 4 units. You see that?
Yes, sir.
And you divide it by 2. So A is 2. Did you get that, Tatu?
Yes, sir.
It's easy. Good. And B is the amount of sin graphs I can draw up to 360 degrees. So let's find, where is one sin graph finished? I'm not sure. It'll be here somewhere. There is one graph, one sin graph. I need to find this, the value there, of that X value there. It will be at negative 1. If you take a guess, what would be a good guess? See,
1 or 2.
pardon?
1 or 2.
It will definitely not be 1, because then we'll finish that graph within 360 degrees.
It will be 90, sir.
No. 90 degrees is here. I think that's like 180 degrees. See. Okay. Did the graph, let's leave B out and say we are a bit struggling with B. We're not 100% sure what B is. What is the C value? Did the sin graph move up or down?
It moved down.
It moved down with how much? 1 unit, eh?
Yes, sir.
Okay. So I have the following. I have Y equals 2 sin BX minus 1. Is that right?
Yes, sir.
Okay, so now I have to get a value Let's look at that coordinate there. It's in the y value is -1. So -1 equals 2 sin bx minus 1.
Yes, sir.
So maybe I can find bx. 0 is 2 sin bx.
Okay.
So sin of what is 0? If you doubt it, you can guess a value. Let's guess 180. So I type in 2 sin, then b is what? If it's 180, it must be 2, because then I can draw 2 graphs to 360. So 2 times 180. That's 0. That's correct. That will give me 0. Okay, this is a long method. It's difficult. I'd rather say, look at the following. I can only up to 90 degrees, which is this is skew. That should be on up to 90 degrees. I can draw a half graph. That's skew, but there's a graph to 90. So I can do another half to 180. So that's one graph to 180. That means it's 2 graphs to 360. So B is 2. B is the amount of graphs I can draw in its own period. So let's look at tan. Did my tan graph, always get the easiest values first. So did my tan graph move up or down?
Down.
With how many units?
2.
-2. Right. How many tan graphs can I draw to 180 degrees?
2.
2. Very good. I can draw one tan graph to 90 degrees. There we go. It's one tan graph finished. Then in green, I'm drawing the second tan graph. And that's 180. Awesome. Good. Let's do another one. If you can get these graphs from a drawing, then you're doing well. Remember, you can always send me specific questions in your textbook that you're struggling with. But that means you need to slightly prepare for the class.
Yes, sir.
Right. Get the value of P for me. There's a cost graph, and I just want to know, what is P? Just don't be caught. Get the value. Test your answer if you have to with the calculator.
It's 1, sir.
P, 1. No. P is the amount of degrees that the graph has moved left or right. The 1 is already front of the cos. P is not the amplitude. P is the value at which the graph has moved left or right. This equation is already y equals 1 cos 1 bracket x minus p. So the amplitude is 1. And we are only going to be able to draw one graph in its period. But that graph is moving left or right.
No, it moved to the left, sir.
Really? I don't know. I'm not that fast. I'm going to draw the normal cos graph here. Make that coordinate there 0 and 1. And this coordinate here is 90. And that one's 180 and -1. So it seems that if we move from this graph to that one, it's actually moved to the right. If I look at this 180 degrees, it's moved 30 to the right. If I look at the 90, it's moved 30 to the right.
Yes, sir.
So P is 30 degrees. Now, sometimes it's difficult because you don't know if it's plus 30 or minus 30. So let's test our answer. So we have the following graph. Y equals cos x minus 30. Because we chose, just going to rewrite it a bit neater. We chose P as a positive value, so I'm just putting positive 30 in there. That means I'm getting negative 30. Now I'm going to test it. I'm going to test it by putting any one of these coordinates in. If I put 300 as an x in, I must get 0 as a y value. So if I type this in my calculator, 300 minus 30, I must get 0 as the answer. Otherwise, my equation is wrong. So I'm typing in cos 300 minus 30, closing the bracket. I get 0 as an answer. Good. That means that's correct. If I had it wrong, if I had y equals cos x plus 30, and then I type 300 in, or I type, say for instance, I type 210 in, I won't get -1 as an answer. Let's test that. I type in 210 plus 30. I get -half. And that does not correspond with that coordinate. So it's wrong.
Yes, sir. Yes, sir.
Good. Right, let's go back to the previous one. We can't do that, can we? You haven't done that. You haven't done trig this year.
No, sir.
So you can't determine those coordinates where they intersect. You need difficult trig to do that. Yeah, difficult trig. Okay, let's do one more. I'll show you how to do it, just as a prelude if we have time, to what we're looking at doing this year. I'm going to repaste that. Okay, we have two graphs here. I'll give you the equations now. We have cos x minus a. That is like the F graph. That one. And then we have a normal sin graph. But there's a slight problem with the sin graph, this blue one. I don't know if you've spotted it. What's the problem with that blue graph? It's flipped around. You see that? The sin graph should look like something like this. Where we had 90 and 1 and 180 there. Now we have 90 there and -1. So the graph is all flipped around. What does that mean? It means this b value is a negative, because a negative value in front of the graph flips the graph around. So I want you to try and get B, C, D, and A. I want you to get all those unknowns. This coordinate here looks like 45 and 1. And this one here, I'm not sure, I can't really see. But that gives you indication of how much the cos graph has moved to the right. Good. Get the values of A, B, C, and D quickly, and then I want to show you something that you're going to do in the near future. You're not going to do that in the near future, are you? No. Yeah. No. Maybe. Get the easiest ones first. Anyone want to take a dip at it? B is the amplitude of the blue graph. Take the highest point, distance to the lowest point. Take that distance, I divide it with 2, and then I realize it's flipped over. So this is -1. Good.
Okay. Yes, sir.
C is what? C is the amount of graphs I can draw to 360. Well, I can only draw a half graph to 180. So I can draw one graph to 360. In other words, you can see there's one sin graph in a whole of 360 degrees.
Yes, sir.
D is if the graph is moved up or down. Well, this graph didn't move up or down. It's still at -1 and +1. So D is 0. It didn't move up or down. And A is the amount of degrees that the cos graph moved. Now the cos graph, they've moved to the right 45 degrees. So that is just 45. And I have to test that answer because I'm sometimes not sure about the sign. So my answer looked like this. And I'm going to put a 45 in. Any one of those coordinates, I can put 135 even if I want to. So I'm going to do this with my calculator. 135 minus 45. And then I'm going to get 0 as an answer. And then I see, okay, yeah, coordinate is 135 and 0. So that's correct. So it's 45. Okay, so now we have the equations. You have f as y equals cos of x minus 45. And you have g as y equals negative sin 1x plus 0. So now, later this year, we are finished now. What we're doing now is not relevant, but I want you to look at it. Later this year, you're going to find the coordinates of A and B. That's why you
Yes,
should
sir.
not do graphs, trig graphs before you've done trig. So now you're going to set these two equations equal. Remember, to get any point of intersection between two graphs, you're going to set these two graphs equal.
Yes, sir.
And then you have to solve this equation. Show you. I'm going to just show you how to do it. You won't understand what I'm doing, but later this year, you're going to say, okay, this is peanuts. You're going to do this. Let's change this one. Let's change sin. So I'm going to change sin to cos. That becomes negative cos of 90 minus x. Okay. So this is second, third. So x minus 45. Now, this is plus. I should have changed cos to sin. It's going to slightly easier. You won't understand the other method. I'm just going to change this cos into sin of 90 minus that angle. I'm not going to do the sum. You're not going to understand this. This is negative sin x. And then I can use those two coordinates. And then I solve that equation. So this is just going to be sin. Maybe you understand what I'm doing now. 135 minus x equals minus sin x. And then I can use, you haven't done this cos diagram, so you don't understand what I'm doing now. Then I'm going to solve those A and B coordinates. We'll do this. This is called general solutions or equations. So you first have to do that and then this, basically. Okay, what you need to do, very important, you need to get that task or assignment going, and then next week ask me questions on it if you're struggling with stuff.
Yes, sir.
Then what you also need to do, you need to get a grip of what you're getting, what chapters. Remember, that's not what I'm doing for you. One of the things that I'm not doing is pacing you. you need to look at all the chapters that you need to finish this term, and then you have to pace yourself. I can't pace you.
Yes, sir.
Right. So if there's
Yes, sir.
big chapters ahead and you only have a month and a half left before the exam, then you need to start pacing yourself. Otherwise, you are going to stuff it up.
Yes, sir.
Okay. Right. Keep well.
You
Yes,
too.
sir.
I'll drop this on the website, on the channel.
Yes, sir.
Yes, sir.
Okay. Have a nice day. Bye bye.
You
Have a
too,
nice day.
sir. Bye.